So I went on a quest the other day to try and find a really good, comprehensive video explaining how the blockchain works, and I honestly could not find one on YouTube. Because to understand Bitcoin and Ethereum and NFTs, you have to understand the underlying technology, the blockchain, and it's not an easy concept to grasp. This script took me hours to write just to try and simplify this concept. So you've seen this technology used for cryptocurrencies and collectibles and memes, but you don't need to understand everything about it, just like you don't need to understand how the banking system works to pay with a credit card. But Bitcoin has become a store of value, an investment, a security, and a lot of venture firms have raised tons of money, US dollars that is, to invest in blockchain companies because blockchain has the potential to reshape the way we think about money. So here's our attempt at explaining the blockchain with Subway.
Clear up the closing doors, please.
We have a blast making these videos, and what we're really good at is taking complex topics and company stories and turning them into simple 15-minute videos or 15-minute slide decks. So if you need help with telling your company's story to your investors, you want to check us out at slidebean.com. So let's start by understanding the concept of a ledger. Ledgers have been used since forever, thousands of years, to keep track of accounts and transactions, whether it was the production of barley in ancient Mesopotamia or the ownership of property to the ownership of people.
Calvin Candy.
So a ledger essentially logs transactions along with other details like the amount and the date and the person who verified it or who authorized it. And that's usually in the form of a signature. So even then, there were some basic security mechanisms in place. For example, ink can't be easily erased. Pages and entries were chronological and numbered, so new entries couldn't really be faked. And for years, ledgers were books. They were kept in safe locations and owned by a trustworthy person. So you essentially trusted the owner of a ledger to not cheat and to not add fake entries or tear out pages. So there are some terms here on keeping a good ledger. For example, signatures to verify that transactions were real, trust in whoever is keeping the ledger, and this is not too different from our current system today. As I swipe to enter the subway, in an instant of a second, the MTA gateway detects a unique code on my card and sends the info to their bank. The bank uses the MasterCard network to talk to my bank, Bank of America. And then Bank of America checks their ledger to confirm I have funds in my account to pay. And then the bank sends a confirmation back via this MasterCard network to the MTA bank. So the MTA finally confirms to the gateway that this is all well and I get to cross. So each bank keeps a general ledger for every one of their customers. And you see a glimpse of that when you get your account statements every month. So your ledger essentially says that you deposited some money to open your account. And then you swipe to pay for lunch. So the bank checks your record to confirm you have enough funds and then adds a record saying that you paid that money to the restaurant, meaning some money moved from your account to theirs. And it gets tracked in the ledger. So then maybe somebody paid you back for lunch. A certain amount of money moved back from their account to yours. Then say you want to buy an extra beer, as overpriced as they are here. So you swipe again, but this time the bank sees your balance is not enough. So the transaction is denied. So as the owner of the account, you are signing and you're verifying those transactions by using your credit card, which in this case functions as sort of a password, the same way your password functions on the online banking. And we think of this as bills exchanging hands and physical money moving from one account to the other. But in this day and age, there's no physical money involved. There's no bills moving from one account to the other. There's just this huge ledger that's keeping track of everything. Numbers being added and subtracted from accounts. Now, your bank's ledger is what's called a centralized ledger. Bank of America owns it. They're the only ones who can make changes to it. And it's their job to maintain it. It's their job to make sure that it's not tampered with or deleted. You essentially trust the bank to keep a good track of that ledger. But they do have full control over the ledger. So there's a remote possibility that the bank could make a mistake or maybe even shut down.
The stock market is now down 21%. What in the world is happening on Wall Street?
Two-year no yields went from 190 to 166.
So Bitcoin was conceptualized by an anonymous person or group that identified themselves as Satoshi Nakamoto. And part of the myth around Bitcoin is that we still don't know who Satoshi is. Anyway, he, she, or they essentially brought together a bunch of concepts, technologies, such as cryptography. And they wrote a white paper that was published in 2009. This was the middle of the real estate market crash in the US, so it inevitably rode in a wave of mistrust in the banking system. By the way, we haven't talked about the 2008 market crash. We figured you've already watched The Big Short, but maybe you want us to cover it, so do let us know in the comments. So anyway, in this white paper, this proposed cryptocurrency offered theoretical solutions for many problems with centralized banking. The fees to send money or accept payments, the trust problem with banks, even the central bank's ability to print new money based on political decisions, really. So Bitcoin as a currency that can be used to pay for things is built on top of a blockchain. And the blockchain is in essence a ledger, just like the one your bank keeps. And we're going to use the Bitcoin example because it was really the first successful implementation of a blockchain. And because it was the cryptocurrency that sparked everything.
Every day I see Bitcoin number 3. This will be better than Bitcoin. You'll get rich overnight.
I went in big. I put in a few million into Bitcoin.
A couple $100,000 at the start, and it's appreciated more than 5,000% since then.
So the Bitcoin ledger, again, that document that keeps track of every single transaction, it doesn't depend on a single entity or a single server. It's not a book, it's rather distributed. It was designed as a way for multiple computers working together, each one of them with a stored copy of the ledger, and with a creative and super secure system to ensure that none of those transactions can be tampered with, or that nobody can tamper with the data. So this ledger is not just a list of transactions. Instead, it's divided into blocks, which is a really clever way Satoshi figured out to allow this thing to work. So each block contains a batch of transactions. Whenever you send money to someone using the blockchain, what you are essentially doing is adding an entry to the ledger, saying that a certain value moved from one account to the other. So in traditional banking, the bank itself is the only entity that can add to the ledger. It's their ledger. But in a blockchain, anybody can add transactions, and therefore it's free. And the technology uses an incredible system, an extremely secure system, to make sure that all these transactions are real. So in a blockchain, transactions are grouped into blocks. On Bitcoin specifically, each block is about 1 megabyte in size, which means that it can store about 2,500 transactions. So a transaction is, again, a log or a record saying that a certain amount of money, a certain value moved from one account to the other, just like with your credit card transactions. In order for a transaction to be valid, the origin account needs to have enough funds, and the record needs to be signed by the owner of the account to verify it's real, just like in the traditional system. Now, as transactions are made between accounts, they are broadcast to all computers in the network, and each one of them begin grouping them into a new block. So let's see how a new block is created in the network. The first thing the computers do is get the code of the last block in the network. That way we know that we are linked between each other. We're linked to that last block, and that gives us a chain. As transactions are received by the computers on the network, they begin listing them inside of this, let's call it an in-progress block. And once the block is finished, they send it to the rest of the network so that instead of pointing to the previous block, they now link to this new latest block in the blockchain. Now, if creating a block were really, really easy, different computers would create multiple blocks at the same time, and they would broadcast them, and then the blockchain would become forked. That means that there would be no way of knowing which of the forks to follow. So by design, creating a new block needed to be hard. Just like each transaction needs to be verified by the sender of the money, each block needs to be verified by the creator, with a process that's intentionally very difficult. Creating a block needs to be deliberately hard so that only one block is created at a time. And on Bitcoin, this is done with a system called proof of work. So as this in-progress block begins filling up with transactions, the computer creating that block automatically begins trying to solve a puzzle. And this is where cryptography comes in. Again, what the network wants for this computer or any computer in the network is to have to go through a lot of work to create a block. But we also don't want other computers to have to go through that same work to check the block to ensure that it's valid. So for this, a cryptography formula is used. And in the case of Bitcoin, it's a function called SHA-256, which is used for a bunch of other things. Your browser is using it right now to connect to YouTube to watch this video. So technically, it's called a hash function. So if you take the information in this in progress block, everything inside it, the number of the block behind it, every transaction that you've added, and you run it through a SHA-256 formula, a number will come up. And that number is really, really unpredictable, and it sounds like random. It's made up of ones and zeros, and it's 256 characters long. And changing any value inside the block will produce a new number. And it's not just one digit different, all 256 digits are going to be different. So since that number is so unpredictable, changing something could give you billions and billions of possibilities, just really advanced math stuff. Though it's very easy to calculate for a computer. So in order to create a block and prove that it wasn't easy, the computer creating the block needs to find a way so the result of this operation starts with 30 zeros. That is, attaching a number at the end of the rest of this data so that the result of the SHA starts with 30 zeros. And here's the trick. There is nothing you can do to calculate that number in reverse. We can know the formula of the SHA-256, but it can't be reverse engineered. Nobody has solved it, and it's unlikely that anybody will anytime soon. The only way to find that add-on number is to try one, and then another, until one of those results gives you 30 zeros. So on average, you will have to test about 1 billion numbers in order to get a result. And this is a lot of work, even for a computer, because it's so many unpredictable options that getting that number right is almost like winning the lottery. The plan here is that a computer should take a few minutes to solve this puzzle. Now, why would anyone burn out their computer to log transactions and try random numbers to find a random number to complete this formula? Because when you create a block, there's another huge benefit to it. You can create money for yourself. So a new block has been created. But remember, this is a ledger. It's supposed to keep track of transactions moving from one account to the other, but it's not a money printer. So if all of these accounts are empty, how does money get created? Where do these coins come from? If you create a transaction from an empty account, it's going to get rejected. Or if you just add money to a random account, it's going to be rejected by the network by design. Except for one. Because the creator of a block gets to add a little reward for themselves. The creator of a block gets to put money into their own accounts. They get to add new coins into the general supply of coins, of money, of currency for the network. That reward is the reason why this is called mining. Essentially, the computer is performing this repetitive task, this boring task of just finding this special number in exchange for this reward that has monetary value. Mining. Once the block is created, it gets broadcast to the network. And once half of the computers in the network adopt it and add it to their own copy of the blockchain and start mining the next block that comes after that, then this block is considered confirmed. And for all sorts and purposes, it's unchangeable. Because remember, each block contains the hash of the previous block. That means that if somebody tried changing something in a block made days ago, it would mean that the hash of this block would change, which would change the hash of the next block and the next block. All blocks would need to be recalculated if you change something. And that is the main reason why a blockchain is such a trustworthy way to store data. Now, Satoshi predicted that as the network grew, a lot more people would join it. A lot more advanced computers would also be joining and start calculating this puzzle. As the network grows bigger, the difficulty of this needs to grow as well. It's adjusted automatically simply by changing the number of zeros required on the proof of work, which is pretty clever. The more zeros, the harder the number is to find. So another important difference is that the amount of coins that get created is also limited. The ledger started with a balance of 0 for everyone. For the first few blocks, the reward for solving the puzzle was 50 Bitcoin. Every single coin in circulation today was created this way, mined by a miner and then sold or transferred to somebody else. And you can actually go and look at the first block of the Bitcoin blockchain. It points to the previous block, which is block 0. It has no transactions because nobody was using it yet. And it had a 50 Bitcoin award for the miner who found it. So the reward for finding a block decreases with time. Right now it's at 6.25 Bitcoin and it continues to decrease. That's the award per created block. And by 2140, all Bitcoins allowed will have been mined and no new ones will be created. Inflation will not be possible. The supply is limited to 21 million coins. Now, at the very beginning, nobody would pay anything to own a unit of this. Someone decided to put a spare computer to mine, wasted a bunch of electricity in exchange for nothing. Numbers on a screen, or technically numbers in a ledger that nobody cared about. But as people began trusting the system, they began assigning value to the numbers in that ledger. Real world value, dollar value, to having an account number with Bitcoin and having value inside that account. And this was cents on the dollar for the first few years. But as you probably know, a Bitcoin is now worth about $30,000.
Bitcoin going bananas. The cryptocurrency topping 61,000 for the first time ever.
Where is it going? It's probably going to 100, then 150, then 200,000.
This is very much a supply and demand game, like the stock market. People assign value to these things and pay other people who own them. If people trust the system, then the value goes up. Mining has become a profitable business too, but not as profitable as you might think. So the award for finding a block today, like I said, is 6.25 Bitcoin, which is not far from $200,000 at the current exchange rate. The challenge is the network is so big, your chances of finding the solution to this puzzle with your old laptop are close to zero. The Bitcoin mining industry looks like this. It's thousands of computers testing values to find a solution to the puzzle. Doing this in the US, for example, would actually end up losing you money because your power bill and the cost of the computers would not be compensated by the rewards that you could get finding blocks. So a lot of mining happens in Iceland, for example, because of the naturally cold weather and the cheap geothermal power. But there are a couple of problems that Satoshi did not address. First, it's power consumption. 0.55% of the world's power consumption is now used for Bitcoin mining. And a lot of that is happening in countries where energy does not come from clean sources, becoming a serious contributor to the greenhouse gas emissions. The worst part of this is that these are computers doing honestly silly operations. You're testing a billion numbers to be able to find one that works to solve the puzzle. More on the technical side, there's a problem of scalability. If you account for the size of the block and how hard it is to find, you'll see that the blockchain is limited to about 2,400 transactions every 10 minutes, which it takes to mine a block. So by comparison, Visa can process about 1,700 transactions per second, which makes your swipe at the turnstile very fast, unlike Bitcoin, which can take minutes or even hours to actually confirm a transaction. Another problem is speculation. Who is to say how much a Bitcoin is worth? The market determines that, just like with any other currency. But Bitcoin's price is so unstable, so volatile, it can't really be used as a currency. It went from 60,000 to 30,000 per Bitcoin in a matter of weeks. If used as a currency, then the price of goods and services would need to change to make up for these fluctuations. Even the machines that are sold, specifically designed to mine Bitcoin, are sold in fiat currencies. So to become a currency and to be used for payments, Bitcoin needs to have a more stable price. It makes no sense as a currency if its purchasing power can halve in a matter of weeks. Also, the network needs to supply many more transactions per second. Other people defend Bitcoin's potential as a store of value, like gold. Gold is the most traditional store of value, and there's a limited supply of it on the planet, and it has problems like security. You can steal gold very easily, I guess. But Bitcoin is potentially safer than that. But once again, until price volatility is solved, it can't really be a store of value. The reality is that Bitcoin today is more of a speculative asset. One that many people buy for the odd chance of the price going up, kind of like a gamble. But this video was not about Bitcoin. It was really about the blockchain. And that is probably the most important, higher potential part of this whole mess. Just on currencies, the Bitcoin blockchain was the first to gain popularity, but there are others. There are other blockchains like Litecoin and Dogecoin, and they're completely separate blockchains with a different ledger, with its own set of rules, block sizes, and algorithms. And the fact that the Bitcoin blockchain whitepaper proved to be successful, the fact that people adopted it and started using it and that assigned value to these coins opened a whole world of developers and cryptographers who decided to put their computers to mine or to develop applications on top of the blockchain or to invent new variations of technology that could be put to other uses thanks to this innovation. So two fantastic examples of this are smart contracts and NFTs. And you should let us know in the comments which of the two you'd like us to cover first. We're already working on them. We wanted to include them in a single video, but that would have been probably 30 or 40 minutes long. So as much as I love writing these scripts, remember my full-time job is running Slidebean and helping other founders with their pitch decks and their stories and their financials and their storytelling. So check out all the ways our product and our team can help you at slidebean.com. And if you want to stay on top of our company and technology teardowns, you should check out our new Company Forensics newsletter. Just hit the link in the description, subscribe, and you'll get an email from us every week with the latest news on startups. Hit that subscribe button and we'll see you next week.